away from the exhaust. You need a certain amount of heat to pump this catalyst. BMW worked with that too, to isolate heat before you work. That was the main technology issue. How to do that. So, we already have catalytic converters on some motorcycles. With the monolith style catalytic converter, it really doesn't affect performance that much. In fact, BMW's Superbike, which is doing really well on the racetrack, surprisingly. Never would have thought BMW would be competitive on the Suzuki Kawasaki. There they are, man. Amazing. They have some aftermarket, I shouldn't say aftermarket, they have some sport model silencers and exhaust systems that you can put on your BMW. Here's the interesting thing. They're still California approved. Give you a horsepower boost. There's a cost. Still cost, of course. There's no free lunch. But this is the only example I can think of a dealer installed, legally installed, aftermarket sort of pipe that's California approved. It is a BMW partner. But you have, I think, a choice of 3 different pipes now for this Superbike. Pretty cool. You can choose your performance level, fuel economy level, and where your performance is. So there's no free lunch ever. Big modification. What you get over here, you pay for something over here. Somewhere around that. Any questions on pollution controls? No. Wildfire, yes, that is an issue. So the BMW's thing helps keep that cool to a point. The biggest issue with wildfires is still your spark arrestor. Because if the wildfires was going to be caused because you dropped the bike, presumably you're there. You know, so when you start the fire, you're not going to just drive away from it. You know, you're going to have at least enough wherewithal to go over and stick it out a little bit, you know, and hang around to make sure the embers don't fire up again. I don't think so anyway. With the spark arrestor, you may start a fire, you never know if you didn't have it, you know, because you left it behind. Are they racing on an officially sanctioned course, or are they just sort of racing for grins and giggles? If they're doing it for grins and giggles, they're risking the fire for that, they're being hideously irresponsible. If it's an organized race, I would think the race promoters would take care of that. Okay. But they're here. They're not going anywhere anytime soon. Catalytic converters, I've seen on the Honda VFR. Kawasaki's got a couple of some of their vehicles. BMW has something on all of them now. And you're going to see more of these in this. This next position. Okay, this is something for the first time you guys are doing something before Tuesday, Thursday, guys. That's because you're not going to be here next Saturday. It's Thanksgiving weekend. Whereas the Tuesday, Thursday guys will be here on Tuesday. So I have to give you Tuesday stuff. Electronic fuel injection. This is very possibly the ultimate pollution control. The best way to maintain your smog levels is to have absolute control of fuel-air ratios. The best way to do that is with fuel injection. A carburetor, by definition, those overlapping circuits, is a compromise. Every circuit is a compromise. You're trying to get something that you want out of it. But fuel injection, you don't have to compromise. Fuel injection was not something that the industry drove. The government drove this. The government said you must do something. They first went after the car industry, and then the motorcycle industry. That fuel injection. Car industry in the early 1980s started seeing fuel injection intentionally put in. There are 3 basic kinds of fuel injection. One of them is called throttle body injection. throttle body injection. Throttle body injection in motorcycles is used quite a bit in aftermarket applications. I believe it's also used by Harley Davidson. Although I can see their latest models to see what you do currently. Throttle body injection, basically what you do is you take the carburetor away, replace it with just a throttle body. A throttle body has a butterfly throttle just like a carburetor does. It does not have a venturi. It doesn't need a venturi. Because we don't use the vacuum in the venturi, the low pressure venturi to bring the fuel. We have a fuel injector to give us fuel. So a throttle body injection, the fuel injector that sprays gasoline in will be inside the throttle body. Then we have port injection. Now, port injection is a lot of different ways. Sequential port injection, tube port injection, all different kinds of things. They're all port injection, which is that the injector is aimed right at the back of the intake valve in each cylinder. So there's one injector for each cylinder. With throttle body injection, there's one or two injectors for the entire engine. With port injection, you have a separate injector for each cylinder, aimed right at the back of the intake valve. So air only goes through the throttle body and then fuel is sprayed in right at the intake point. The third type is direct injection, where the fuel injector is sprayed directly into the ignition chamber. That requires somewhat higher fuel pressure than regular fuel injection. Audi, Volkswagen, and so on are using a lot of direct injection, as is BMW, in their automobiles. Now, start seeing the direct injection of some Aprilia motorcycles. I like Aprilias. I look good on Aprilias. So that's direct injection. It'll be one of those three. Direct injection actually is kind of like a stepchild of the diesel industry too, because diesels are also direct injected into the combustion chamber. Getting electrically controlled gasoline injection in the chamber took a bit more research before they got the hang of that. Direct injection, mainly very high pressure direct injection, mainly used for diesels. And more recently, we're seeing this in gasoline engines. A diesel injector is a big thing. A small injector for diesel is about the size of this marker. Big injector for diesel is about the size of that milk bottle right there. It's a mechanical injector system. There's actually a fuel distributor that sends the fuel to whichever injector needs it at a given time, and designed to withstand the tremendous pressures that occur inside a diesel engine. Electronic fuel injector that direct injects is usually much longer unit than for gasoline and electrically controlled. It took a bit of research to be able to withstand the pressure. You don't want the combustion chamber pressure to push the injector back open and have combustion gases going the wrong way up your fuel pipe. This can be bad. Use your imagination, multiply by 2, get an idea of how bad it can be. But they got most of those bugs worked out with direct injection. Direct injection has certain advantages. The main advantage being volumetric efficiency. I'm bringing in through the throttle body a certain volume of stuff. And usually with a carburetor or port injection or throttle body injection, I'm bringing in air and fuel. The fuel is taking up some space. If I can bring air only in, I can get in more air because there's no fuel taking up the space. And then once the valve closes, I can inject the gasoline later and force additional stuff in. This allows me to get more fuel in there at the engine than I did before. And improves my volumetric efficiency and improves my performance. That's the main reason they did it for gasoline. Not necessarily. I don't like throwing it. Not unless it has a cable override. Toyota's had some issues with that recently. This throttle body injection. The injector is actually the throttle body. Now a strange valve arrangement on this one. And this is port injection. A very badly designed port. I think that the artist just got lazy. Couldn't find their 45-degree thing. Because that injector really should be aimed at an angle toward the back of that valve. I didn't know this. I didn't know very well. Now, there's only 3 ways that we can vary our fuel delivery. One of them is to change the size of the quantity of the injectors. Now, it's really hard to change the size of your injector while the engine's running, because you have to take the injector out and put the injector. And that's just not going to work. You can change the fuel pressure. If I increase the fuel pressure, I'll increase the fuel delivery. Or I can change how long the injector is spraying, how long the injector is turned on. That's the way we usually control fuel injection, is by how long the injector is turned on. Now, changing the size or quantity of injectors is doable. I didn't say it was impossible. Changing fuel pressure, we do this a lot, fuel injection, under certain circumstances. But changing the size and quantity, we generally don't for a street application. I did it when I tried to run that speed record run in an old Mirage. That was a K75 750 triple. It was fuel injected. It had 3 stages of fuel injection, 3 stages of injection, with one injector, the second injector, and the third injector on top of that. And they came in sequentially, depending on what engine speed I was going. The third injector was spraying water, by the way. And it turned on if the detonation sensor knows the engine was not. It turned on the water injector, which would spray water into the engine, which would create steam, lower the combustion chamber temperature, stop the knocking. At the same time, you can superheat the steam and increase the pressure inside the combustion chamber. You get good power. So I had 3 stages of that. So that was changing the quantity of the injectors. There's advantages to that. You can get to that. But really unnecessarily complex for riding on the street. Changing fuel pressure, we do. That's a very common way of handling certain situations. But changing how long the injector sprays is the #1 way that we handle electronic fuel injection. Okay? The large injector allows more fuel. Get a bigger injector, it's going to spray more fuel. But you have worse atomization. The spray that goes in is more liquid, a lot less mist. And I need to have good atomization to get good vaporization, good power. So there's only so much I can increase the size of my injector without losing my atomization. The smaller injector allows less fuel but has better atomization. There's been some changes for the Lucas injectors. We'll talk about that later on too. But we can't change the injector size while running. We can change the number. It's possible. But it requires some fairly sophisticated computer programming to make that work. Injector size, we're stuck with whatever size we put in there. We can change the fuel pressure. By changing the fuel pressure, we get better fuel flow. That seems obvious. Hard to control it precisely, but we do use it in some cases. Usually, we're maintaining fuel pressure in a steady state so that we can control how long the fuel is turned on to control exactly how much fuel we're putting in. The injector on times. The longer the injector is activated, the more fuel it sprays. And this is the one we control on the computer. Electronic pulse, usually 5-volt pulse, turns the injector on and off. When it hits the 5 volts, the injector turns on, it sprays. The quantity being preset by the amount of fuel pressure given, which is held steady, and then turned off again. So depending on what engine speed you're at, the injector speed is going to, or how long it stays on, is going to be changed. Since it's an electrical signal that's doing this, I graph this. This is voltage, this is time on this axis. The injector's off. When it turns on, it'll turn on. This will be 5 volts right there. And then when it turns off, it goes back to 0. To make it turn on longer, I just leave it on longer like that.